Just take a second and look around you. Everything you see, everything you've ever touched, every star, planet, and galaxy we can spot in the night sky, all of it is just a tiny, tiny fraction of what's actually out there. So today, we're going to dive into the other 95%, the huge, invisible, and frankly, deeply weird dark side of our cosmos. And this chart really just puts it all into perspective, doesn't it? It's pretty humbling. Everything we know, all the normal matter, that's us, the Earth, the Sun, that's only 5% of the universe. The rest? It's a complete cosmic enigma. It's split between two things we know almost nothing about. 27% is something called dark matter, and a truly staggering 68% is dark energy. So what in the world are these invisible forces that completely run the show?
All right, to get a handle on that 95%, we've got to investigate these two mysterious characters. You've got dark matter, which acts like a cosmic glue holding things together. And then you've got dark energy, which seems to be doing the exact opposite. It's pushing everything apart. So let's start our cosmic detective story with the glue.
So the first clues that something big was missing didn't come from what astronomers could see, but from how things were moving. Back in the 1970s, astronomers like the brilliant Vera Rubin were studying how spiral galaxies spin, and the results just made no sense at all.
Okay, so according to everything we knew about gravity, the stars way out on the edges of a galaxy should be moving much, much slower than the stars near the crowded center, right? But what they saw was that the outer stars were moving just as fast, sometimes even faster. And that was a huge problem. It's like watching a merry-go-round spin so fast that the horses on the outside should be flying off, but somehow they're just not. Something invisible had to be holding them in place.
And this is exactly what they found. Look at these graphs. Instead of the speed of the stars dropping off as you get further from the center, the lines just stay flat. This was the data that had everybody scratching their heads. The only way you can explain these flat lines is if there's a massive, invisible halo of something surrounding the entire galaxy, providing all this extra gravity needed to keep those fast-moving stars from flying off into deep space.
This quote, from the original paper by Rubin, Ford, and Thonard, really just captures how big of a deal this was. They're basically saying, look, we've checked the math. The only way this works is if there's a ton of stuff out there that we just can't see. The conclusion was inescapable. Fast forward a few decades, and we got the smoking gun, the bullet cluster. What you're looking at is two galaxy clusters that have smashed into each other. The normal matter, that hot gas, is shown in pink. It all crashed together and slowed down, like a cosmic car pileup. But most of the mass, which we can map by how it bends light, is shown here in blue, and it sailed right through the collision like nothing even happened. This was it. Direct proof that dark matter is real and that it basically ignores normal matter.
So here's the key takeaway. Dark matter is like the universe's invisible scaffolding. It's the cosmic cement that provides all that extra gravity that holds entire galaxies together. Honestly, without it, big structures like our own Milky Way probably would have just flown apart billions of years ago.
Okay, so that's dark matter. But now we have to talk about an even bigger and frankly weirder mystery. Just as everyone was getting used to the idea of this invisible cosmic glue, a discovery in the late 1990s revealed another force that's doing the complete opposite. It's pushing the entire universe apart. For pretty much the whole 20th century, the assumption was simple. The universe started expanding with the Big Bang, and gravity has been trying to pull it back together ever since. So the expansion must be slowing down, right? But when scientists used distant supernovas to measure that slowdown, they found the exact opposite. The expansion of the universe isn't slowing down. It's speeding up. And so cosmologists just gave a name to whatever was causing this crazy acceleration: dark energy. It's some kind of mysterious, repulsive force, a sort of anti-gravity that seems to be woven into the fabric of space itself. And the weirdest part, as space expands, you get more of it, pushing everything apart faster and faster. This discovery was a total shock that completely turned cosmology on its head.
So while dark energy is still this profound mystery, scientists are on the hunt for the actual particle that makes up dark matter, and this search is one of the biggest deals in particle physics today, with these incredible experiments running all over the globe.
Which of course brings us to the real challenge here. I mean, how on earth do you find a particle that you literally can't see, you can't touch, and that barely interacts with anything? It's passing through you, through the Earth, right now, as if none of it is even there. It really is like trying to catch a ghost.
For a long time, the #1 suspect has been a particle called a WIMP,
which stands for Weakly Interacting Massive Particle. And its name is basically its job description. For it to be our dark matter particle, it has to be massive to account for all that gravity. It has to be weakly interacting, which is why it's so ghostly. It can't have an electric charge, otherwise we'd see its light. And it has to be super stable. You know, having survived since the very beginning of the universe.
So how do you hunt for a ghost like that? Well, you go to one of the quietest, most isolated places on Earth. We're talking nearly a mile underground in an old gold mine in South Dakota. That's where the Lux Zeppelin detector sits, shielded from all the cosmic rays and radiation from above. Inside is a huge tank of ultra-pure liquid xenon. And scientists are basically just listening, waiting, for the 1 in a trillion chance that a WIMP happens to bump into a xenon atom, creating a tiny flash of light, a faint whisper in the dark that finally says, "Here I am."
So while that hunt for dark matter is going on deep underground, dark energy is out there raising these even bigger, more profound questions. Questions not just about what the universe is made of, but about its ultimate fate. Where is all this accelerating expansion actually taking us?
The astrophysicist who actually coined the term dark energy, Michael Turner, he calls its true nature the biggest mystery in all of science. And he's not wrong. If this stuff makes up 68% of everything, what is it? Where does it come from?
Well, there are a couple of big ideas on the table. One is that dark energy is just a fundamental property of space itself, what Einstein called the cosmological constant. The idea is as space expands, you get more space, and so you get more of this energy. A newer, really fascinating idea is that it might be connected to supermassive black holes, that maybe, as they grow, they're somehow cosmologically coupled to the expansion, generating this repulsive force. But really, the jury is still very much out on this one.
And all of this leaves us with this final, kind of haunting question. What happens in the end? If dark energy keeps getting stronger, it could lead to something called a big rip, where everything, galaxies, stars, planets, even the atoms in your body, gets torn apart. Or if it just stays constant, all the other galaxies will eventually accelerate away from us, beyond our view, until our own galaxy is left all alone in an endless, empty, dark void. The ultimate fate of our universe is hidden in the nature of that 68%, the part we have yet to even begin to understand.